So what we want to do is solve questions on the electricity that we discussed earlier and has been posted online. As see, these are all down kind of questions or past questions so that we can test what we have done so far. So we'll be solving questions at least. We are hoping to solve at least more than 10 questions. More than 10 questions. Alright? So let's start with this one on the board first. So if you can see the question on the board, let's read together. So it says that according to Ohm's law, according to what? Ohm's law, the ratio V over I is a constant for. So what is Ohm's law? Ohm's law is V directly proportional to what? I, right? This is what V equal to I R. So this is the constant because R is equal to what? V over I. So that constant is for electrolyte, diodes, transistor, and silver, or all of the above. I know that some of you know the answer, but if you have followed our lectures in the past few weeks, we discussed diodes, we discussed electrolysis. I don't know if I've posted it, but when we're discussing diodes, we said they are conductors that are called ohmic conductors. Ohmic conductors, that is conductors that obeys or follow Ohm's law, right? So they are what? Metallic conductors. Metallic conductors, simple. So the electrolyte does not follow Ohm's law, doesn't obey Ohm's law. Transistors does not obey Ohm's law. And transistors and diodes are made up of the same thing, semiconductors, alright? Semiconductors are material that when you increase the temperature of that material, the conductivity downward increases. It will conduct more and more. So that is against Ohm's law. Ohm's law says that temperature affects resistance. Are you getting it now? So which of them is the metal? Silver, correct. That's the correct answer. Now the next one, please understand that. The next question. Which of the following is not an effect that can produce by an electric current, or that can be produced by an electric current? So let me put that can be here. So which of the following is an effect that can be produced by an electric current? And heat is produced by an electric current? Yes, that's why you have your pressure iron. If you pass current, listen, you pass current through a very high resistance material, heat will be produced. Heat will be generated. That is the source of your pressure iron. That's the principle behind your pressure iron. They pass current through a very high resistance material. I think you understand. Light, yes. Once you pass current through a very high resistant material, it produces light also apart from heat. You know your tungsten bulb, you know those bulbs, those yellow bulbs. Yes, that's the principle. You pass electric current through a tungsten wire. Tungsten wire. It will become hot, white. That is what produces the light you are seeing. Got it? Yeah, got it, right? The next one. Sound, of course. Electric frequency can cause production of what? Sound. Motion, an electric cause motion, yes. Electromagnetism. That is another cause. I'm going to discuss electromagnetism within this week, but it's not just on secondary school level. Alright? I'm going to take it to the high, so you watch that video and take the one that belongs to you. Of course, that one will give you more understanding, but I'm going to discuss electromagnetism within this week. I get me now. So, electric current can produce what? Motion. So, which of the following is not? Which of them is not? None of the above is not, because all of the above. Right? You understand? Because all of the
Sound,
above.
sound.
Yes. Electric frequency produce sound.
Television.
Yes.
Television.
Yes. How do you convert sound from microphone to speaker? Microphone receives it and transmits it to electric what? Signal or frequency. That one at the other end produces the sound. Do you understand? Yes. Electric frequency causes sound of varying notes. Causes what? Sound of varying notes. Number 3. Instead of EMF, 2 volts and internal resistance 1 ohm supply a current of 0.5 ampere to a resistance whose value is to a resistance whose value is okay, we're looking for the value of the resistance. So I don't know why is it volt watt like this. Supposed to be ohms. So I guess it was a typographical error. Please ohms auto. So we are looking for the external resistance. And if you follow the lecture that is, the lecture that is, the lecture that I'm gonna have preceding this our lecture now, or this past question, you will know that what I take the formula of what V is equal to IR, and EMF is equal to what? Remember, EMF is equal to what? I open at the what? PR plus small r. Do you remember? So EMF is equal to I open at the PR plus small letter r. If you don't understand it by now, I advise you go back to the video, go to the YouTube page, check electricity, go back to the video and watch it so that I can understand it. So now let's solve this question. So what we have we have EMF is the resistance is what? 2 volts, current is what? 0.5, that's 1 over 2, let's use 1 over 2. Current is 0.5, 1 over 2, this is current here. So internal resistance is 1, so R plus 1, we are looking for capital letter R, cross multiply, this 2 will multiply this one, that's what? 4 equal to what? R plus 1. So 1 will come here, that's 3. So R is what? 3 ohms. This implies that R is equal to what? 3 ohms.
Yes.
So that is correct. Option E. Alright, we'll continue. Now, this is another question. Look at this question clearly. You can see there's a diagram there. And let's quickly dive in and solve the question. We have in the circuit below, the ammeter reads a current of 3 ampere when R is 5 ohms and reads 6 ampere when R is 2 ohms. The value of the unknown resistance S is, so they were taking the value of R and we're getting the current. I'm getting that. But this one was constant, right? So let's establish the formula that we record. First of all, what is the total resistance here? Total resistance is what? Total resistance is what? R plus S. R plus S. Can you see that? R plus what? R plus what? R plus S, right? Hmm? So I hope this one is very clear. That's my mission. So R plus S. So in the first instance, V is equal to I R. Hmm? So since the both things is the same, eh, we're gonna say we're gonna say the first one when R is equal to how many? Okay, when R is equal to what? Okay, let me make it more simple. Let's make it more simple. If V is equal to IR, it means that V is equal to what? I open bracket what? R plus X. Why? Because this R is the total resistance, and the total resistance is this plus this. Why are you adding it? You are adding it because they are connected in series. There is a way to add or find the total resistance of a resistor that are in parallel. But when they are in series like this, line by line, and the same wire is passing through them, then you add all the resistors. You add what? All the resistors. Eh? So for this case, this is equal to IR. This R is the total resistance, which is what? R plus X, right? So without say since the voltage was the same throughout the time when they were changing R, I get to you. What does that mean? It means that when R was when R was 5 and I was what? 3, when R was 5 ohms and I was 3 ampere, this voltage was what? 3 open at what? 5 plus S. Then when R was what? R was 2 ohms and I was what? 6 ampere. The voltage was what? 6 open bracket 2 plus what? X. So if V and V are the same, the voltage was not changed at all this period. It means that this is equal to this. So 3 open bracket 5 plus S is equal to what? 6 open bracket what? 2 plus X. You can expand it. Expand it. 15 plus 3S, 2 times 2, 6 times 2, 12 plus 6S. So connect like this, S goes there, and you get what? 3 equal to what? 3S, and your S is equal to what? 1 ohm. So the value of S is what? 1 ohm. You can see that, right? Now, we have another question again that we want to solve. So, now the question says, what is the resultant resistance of the circuit in the figure given above? Resultant resistance simply means total resistance or effective resistance. And whenever they say resultant resistance, it means that we have more than one resistance there. So we are looking for the combined effort, the combined effect, the combined resistance of all the resistors. Are you getting it now? So 1, 2, 3, 4, what is the combined resistance? So before we do that, let's go over some points. Remember, when resistors are in series, you add all the what? Resistance, right? But when resistors are in parallel, what do you do? Parallel, what do you do? You do what? You find the inverse of the sum of the inverse of the sum of the inverse of all the resistance. Are you getting it now? Now is this a parallel or series connection? Which one is it? Parallel or series? Now, if I call it parallel because of this, I call it series because there's just one wire there and at the end there was another wire. So what you do is that you look at it very well and see that this wire entered there and split into two. So these two that the wire split at this junction makes these two a parallel connection. Then the wire came back and joined and connected this one, makes this one a series. So this one is a series. Both of them are also in series with this one. That is when you combine them together. You understand? So the best thing is to combine these two so that it is one. So we'll do it like this. I try to do something like this. Combine the two of them so that you have something like this. Then one now, then another one here. You understand? So this one will be 3, this one will be unknown, let's call it S. Then this one will also what? Be 4. So once you find this S, which is combination of this and this, then we'll now add it, this plus this plus this. That will be the total effectual resistance. So that is the principle or way or method of solving all these equations. The ones that you can combine them before you now solve everything all together. So let's solve that to first 2. So for that you have 1 over S. Remember, two of them go together is S. So 1 over S is equal to 1 over 2 plus 1 over 2. And that will give you LCM of 2, 1 plus 1. That is what? 2 over 2. You understand? So that is what? 1. So S is what? S is 1, right? So 3 plus 1 plus 4. What would that give you? Total resistance or effective resistance is what? 3 plus 1 plus 4. That gives us what? 8 ohms. So that is option B. Option B, this one is correct. Option B is correct. Are we together? Alright, to round up the question for today, let's take a look at these 3 questions again. The first one is what? A cell of internal resistance 0.01 what? Ohms can be measured accurately using the ohmmeter, potentiometer, electroscope, meter gauge. What can you use to measure the resistance of a cell? Ohmmeter. As you said it, because you see ohms there. The question is there like ohmmeter. What they use to measure resistance accurately is meter gauge. Meter gauge is used for measuring resistance accurately. Is that okay? Next one. A radio is operated by 8 cells. Each of those cells EMF 2.0 volts connected in series. If 2 of the cells are wrongly connected, the net EMF of radio is now. Instead of it to have series connection like this, for each of them, I get to 1, 2, 3, 4, 5, then 6. Then 2 of them are now wrongly connected like this. You now solve it like what? The way you solve your resultant vector. You know, these 2 ohms, that's 2 plus 2 plus 2 plus 2, that's what? 12, right? Because you see, 2 times 6, 12. So 12 volts is going this way, while 4 volts is going that way. So 12 minus 4, that's what? This one will be negative, this one will be positive. 12 minus 4, that's what?
Minus 8.
8 volts. So the total volt is what? 8 volts. Can you see? Instead of giving you 2 times 8, which is 16, they're getting it. Why? Because of just simple mistake. Can you see that? Eh? That's why anytime you change your battery, if one is this way, the other one is that way, no current will produce. Because your own 1.5 minus 1.5, that is 0. Uh-huh. But if I have it watch, let's say 1, 2, 3, 4, then 1 is now wrong.
You see on.
You on. If you have it 4, 1 is
Okay.
on.
But if it's 2 minus each other, so
You will subtract.
if it's 3, 2,
1 will subtract. So it will not be 1.5, but 2, it will not be, the energy will not be much. You know, what you are using it for has a particular voltage before it comes on, right?
today me I'm just learning this one.
So the next one, let's clean this part of the board so that we will be able to solve the next one. So the next one says, a cell of internal resistance R supplies current to a 6 watt, 6 ohm resistor, and its efficiency is what, 5%. Circuit, this type of circuit, or sometimes circuit is considered as a machine. And you know machine have efficiency, right? Machine have efficiency. And what's the efficiency of the machine? Output, over what? Input. What input over what output times 100%. So the question is, what is what output? Output is the total voltage. Sorry, input is what? Total voltage of the cell. Then the output is the voltage of the external resistor. So input is the total voltage, that's EMF of the cell. While output is what? Voltage of what? The voltage of what? The energy, that's the voltage of what? The external calculated or determined as the external resistance. Are you getting that? So let's take you one by one. Output, we now say V is equal to what? IR. What is I? What is R? R is the external resistance, which is what? I times what? 6, which is what? 6I, right? So input is everything, which is what? I open at the R plus 1 letter R, right? So what is I? We don't know I. What is small r? 6. What is big R? 6. What's small r? We don't know yet. That's what we're looking for, right? Good. So efficiency is what? 35%, right? So which is equal to what? Output, which is what? 6I over what? Input is what? I open bracket 6 plus R. 6 plus 1 letter R. Are you with me? This I will cancel this I. Right? Remember times 100. Are you with me now? So we will see this pattern more small here. We discover that 25 here is what? 4. 25 here is what? 3, right? So cross multiply. Everything here times 3. That's 3 open bracket 6 plus 1 letter R. Then 1 here times 6 times 4. 6 times 4, that's what? 24, right? So I'll be 6 divided by 3, right? 3 here, 3 here how many? 6 plus R, 3 here how many? 8, right? So R is what? 8 minus 6. That is what? 2 ohm. Option what? Option D is the correct answer. 2 ohms. Right? I hope you know how to solve it. You can play the video over and over again to understand how to solve it. Thank you.